Hi, my name is Japreet.
Hi, my name is Sachin, and today we are going to represent our final project for data mining, which is online news popularity. So this would be the flow of our presentation. We would have introduction, problem statement, data overview, then data cleaning and modeling, where we have three different objectives, and then visualization using Tableau, and then we have the implementation on Amazon Web Server. And this is the website from where the articles are published. These are the different categories of the under which we can uh, publish our articles, like social media, technology, business, entertainment, and world. So this is how the Mashable website looks like. So next would be our project aim, in which we have three different problem statements. One would be to predict the number of shares, which is our basic requirement from our project. And what we have got is we have further extended this requirement to predict using a popularity variable, which would be our binary variable, where we have classified this based on the number of shares. For number of shares greater than 1400, the popularity would be yes, and then for less than, it would be no. To predict an ordinal outcome for the popularity level, we have further extended this variable into an ordinal kind of variable, in which we would be further classifying the number of shares into less than 1100 category for low popularity, for medium for 1100 to 2100, and high would be greater than 2100. This is based on the average number of instances we have in the data set, which are close to 40,000. So we have just sorted this based on the shares. And what we have found is if we consider for 33% of the data set, that would be the share would be less than 1100, and for 66% it would be 2100. So that's how we have classified this as a threshold value. The first objective would be to visualize a data set, and which we have done using Tableau. The next topic is dataset overview. The dataset which we have is was acquired on 8th of January 2015. It has total 39,644 instances and 71 attributes. Out of those 71 attributes, 64 are independent predictors and 4 are non-predictive, like URL, time delta, and we have a couple of dummy variables which was parsed in the dataset. Day and article type are those two variables. And we have three target variables: number of shares, popularity, and popularity level we have introduced on our own. The next thing is data cleaning. The process data cleaning involved four different steps, in which this URL tab URL attribute has year and month in it. So we extracted this based on these formulas using Excel. The next one was a parsing weekdays, for which this is a non-predictive variable which I was talking about, and this is how it was parsed. And this was the variable we have created using this formula in Excel. Similarly, we have done this for article type as well into dummy variables. And the fourth one is the target variable, popularity and popularity level, which we have introduced, and this is the criteria we have chosen for it. And these are the two target variables which we have extended. So the first objective is to predict the number of shares, which is a continuous variable. And for the first approach is using a kitchen sink model on linear regression. And the result we have obtained is R square 2.5%, and adjusted R square is close to 2%. The MSC value you can see is very high. The second approach was using kitchen sink on decision tree. We can see that the mean square error value here again is too high, and so we went on ahead and gave an approach 3, where we use principal component analysis. This dimensionality reduction technique gives us components which have high variance. So you can see here the cumulative cutoff value we have considered is 0.8, and so this is the graph, the eigenvalue plot here. So we have considered these many attributes from principal component. The fourth approach we have used is principal component on decision tree, and we got this output. So you can see the MSC values are very high here, and the adjusted R square was very low, and that means only 2% of the variance in the target variable, which was shares, can be explained by our predictor variables. So as we have this case similar to what we have in stock price prediction example from the book, where exact stock price value prediction cannot be made, and in situations we usually go ahead with a threshold value on continuous target variable and try to predict a binary categorical variable as a target. So what we'll be doing is predicting our popularity variable, for which we have considered the threshold of number of shares as 1400. So our objective 2 involves predicting popularity variable, which is a categorical variable. model. So we'll go ahead with logistic regression and decision tree in our using a kitchen sink model where all 71 attributes are involved. So we can see the output gives us a accuracy of 65% using logistic and 64% using decision tree from our approach 1. The approach 2 gives us the output of 63% logistic, 64 in decision tree, and 62% in gradient boosting, which is an extreme extended form of decision tree. So we can see here we have used variable selection technique, which is basically filtering out attributes on R square and chi-square values. After the filtering the values, we have only these many left out variables, and we can see here approach 3 used principal component analysis on the same all three of the modules, in which we received the accuracy of 62, 62 and 63%. So all the more they are all similar. Principal component analysis gave us a different set of filtered attributes based on the variance. The conclusion for our objective 2 can be seen here. Again, the kitchen sink model will give us the accuracy which is very high, 65% on logistic regression, because it used 71 attributes, so it was too complex, and on compromising only 1% accuracy. When we built using a variable selection technique, we have this model as very simple, and considering the fact that the value of false negative values is more alarming to false positive, a selected model should have the least false negative values here, which is more of a cost effective model for business strategy. So as a result, we would prefer decision tree with variable selection technique out of all three approaches we have chosen for objective 2. The objective 3 was to predict ordinal popularity level, in which we have further classified popularity as low, medium and high based on number of share values as 1100 and 2100 threshold. So approach 1, again similar kind of approach using kitchen sink on logistic and decision tree. We have obtained accuracy of 48% and 47% respectively. And in approach 2, we used a variable selection technique on logistic regression decision tree to filter out the number of attributes, and we saw that the evaluation criteria gives us 47% and 47% accuracy. In approach 3, we used principal component on logistic regression decision tree, and in where we again received a similar kind of accuracies, and we further on came to a conclusion which was similar to objective 2, that with the kitchen sink model, although we received higher accuracy, but the model was too complex, and on compromising only just 1% of accuracy, we built better models based on some dimensionality reduction techniques. And again, using the same logic with the minimum number of false negatives, we came up with the final conclusion that logistic regression with variable selection technique for our objective 3 would be the better choice. Coming to our fourth objective, in which we have the visualization done through Tableau. The public link available is here. You can see this is the dashboard where we have uploaded the Tableau workbook. And the first insight we have received from the data is CS conference by CENET in Jan makes people share more technology related articles. So we can see here the number of shares in Jan 2014 is almost double than in Jan 2013. Mobile device is preferred to read Mashable articles. You can see here cities like California, Texas, New York and Massachusetts has most number of authors, and in most authors post during night hours. And the reason we can come up with this is in Jan people share maximum technology related articles because the company CNET organizes CES product launch conference annually in the month of January, and this is the time when people stay active and share more articles on technology. The second insight we have received is like Christmas holiday and Black Friday week make people visit lifestyle and related Mashable articles even more. You can see from the dashboard here, authors in Wyoming publish more lifestyle related articles, and such articles are more shared during last few months of the year. And these can be attributed like for Christmas holiday, Black Friday and Labor Day bring heavy discounts on shopping, and this makes people visit lifestyle related Mashable articles even more. The third insight was New York City is the city with maximum business-minded crowd. The reason behind this is most of the authors in the New York publish articles on Mashable.com during night, and people working in New York love to read. Most of them have the business-related articles read, and hence we can come up with a conclusion that New York has the maximum number of business people. The final thing was we implemented it with the Amazon web server, where we have this website. This is our website. We implemented our decision tree with the variable selection technique, and this is the number of attributes we have got from the filtered dimensional reductionality technique. And so if we give the number of words in our article like 1000, and then all these variables like we can see here, we can just run this and see the outcome, and you can see our model shows that our article is going to be popular. Similarly, putting our same logic, if we give here the number of words in our article more, we can see that the article will not be popular, and hence this can be attributed to the fact that people read on articles which have less number of words, and this was implemented using if else logic from the decision tree with variable selection model which we have derived, and it was coded in PHP. Thank you.